Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I am perfectly audible and visible to every one of you. Quickly give me some thumbs ups in the chats so that I'll get to know I'm perfectly audible and visible to everyone. Quickly let me know in the chats. Welcome back guys, welcome back. Just give me a second. Let me fix certain things and we shall be starting, okay? Let me fix certain things and we shall be starting. Till then you can let me know in the chats if all of you can hear me. If I'm perfectly audible and visible to everyone. Yes? Perfect guys, perfect. So, as you all must be knowing, tonight it's going to be the second session from the chapter mole concept. Before starting this particular session, I would want you guys to let me know in the chats whether you all have watched the first session of the mole concept. Let me know quickly in the chats with the thumbs ups. Let me know quickly in the chats with the thumbs ups if all of you have watched the first session of the mole concept, which I took, I think, 3 days back. Just let me know quickly in the chats. Quickly, everyone. Yes? All right. So I can see majority of the students have already watched the first session of the chapter mole concept. So then it's going to be perfectly fine for all of you. The ones who have not watched it yet, I would want you guys to watch the first session of the mole concept so that you can understand the second session of the mole concept properly, because this chapter is completely linked, right? If you are missing one session in between, then you won't be able to understand the upcoming sessions in this particular chapter, right? And again, let me tell you, this is the most important chapter as far as your physical chemistry is concerned. If this particular chapter is strong, that means your entire physical chemistry can become easily strong, right? If there are doubts, if there are issues in this particular chapter, that means there will be issues in the whole physical chemistry. So this particular chapter, it forms the foundation of your entire physical chemistry. Okay? So, if you remember, my dear students, in the first session of the mole concept, I talked about the basics of the mole concept, right? Like I gave you certain terminologies, like atomic mass, molecular mass, molar mass, and few questions related to them. Perfect. And what all things we are going to cover in the today's session. We shall be first of all discussing the average atomic mass of the isotopic mixture. That is going to be our first topic. Average atomic mass of the isotopic mixture. We shall be discussing the calculation of moles and the questions which can be asked related to the moles, right? All those things I'll be doing in the today's session. I'll be showing you exactly the application of the mole, where all, in which type of questions this mole is used, right? And at the end, if we got time, we'll be talking about the average molar mass of the gaseous mixture as well. So this is going to be the table of content which I'll be following in the tonight's session. Okay, perfect. So let's get going then. Let's get started with the today's session. I'm starting this session with a question, right? In the last session, if you remember, we discussed about molecular mass, molar mass, and atomic mass. So let's try to solve one question, one nice question, right? And after that, we'll go into the actual stuff which we have to do in the today's session. Okay? So let's have a look, people, what this question is all about. The question was asked once in your JEE mains examination, and it's of proper NEET standard. Okay? Look at the question carefully. As far as this particular question is concerned, we have got two elements X and Y. This X and Y combines to form two compounds. One is XY2 and another one is X3Y2. So basically we have got two elements X and Y. X and Y are combining to form two compounds. One is your XY2, one more is your X3Y2. Perfect. So two compounds we have. As per the question, 0.1 moles of XY2, 0.1 moles of XY2, it weighs 10 grams, and 0.05 moles of X3Y2, it weighs 9 grams. The atomic weights of X and Y are. I hope you got the question, right? Now, my dear students, let's exactly see how do we solve this sort of equation. Understand people properly. As far as the question is concerned, how many compounds do we have? We have got 2 compounds. One is your XY2, one more is your X3Y2. These are the 2 compounds which we are given with, right? Now, my dear students, the first point which is given as per the question, what is that? As per the question, it's mentioned that 0.1 moles of XY2, 0.1 moles of XY2 weighs 10 grams. And at the same time, 0.05 moles of X3Y2. It weighs how much? It weighs 9 grams. These are the 2 basic statements which we are given with. Okay? Now you tell me, if I talk about this compound XY2, since as per the question, 0.1 moles of XY2 weighs 10 grams, correct? 0.1 moles of XY2 weighs 10 grams. Now you tell me, by using the unitary method, can I say 1 mole of XY2 weighs 10 divided by 0.1 grams, which will be how much? Which will be 100 grams. Since as per the question, 0.1 moles of XY2 weighs 10 grams. So 1 mole of XY2 weighs how much? It weighs 100 grams. Now, if you remember, mass of 1 mole of a substance, what do we call that as? We call that as the molar mass. Since we got to know the mass of 1 mole of XY2, it came out to be 100 grams, right? Perfect. So can I say this 100 grams is basically the molar mass of XY2? Absolutely. We got to know the molar mass of XY2. How much? It is 100 grams. That means mass of 1 mole of XY2 came out to be 100 grams. Point number 1. Now point number 2. What is point number 2? I'll use the similar procedure in the second case as well. Have a look properly. 0.05 moles of X3Y2, it weighs 9 grams. So can I say, by using the unitary method, 1 mole of X3Y2, it weighs 9 divided by 0.05 grams, which comes out to be 180 grams. Correct? So if I ask you what this 180 grams is, can I say this 180 grams, it is basically the mass of 1 mole of X3Y2. And we know the mass of 1 mole of X3Y2 is something which I will be calling as molar mass of X3Y2, right? So basically, right here, I got the molar mass. I got the molar mass of what? I got the molar mass of X3Y2 and it came out to be 180 grams. So till now, what did we calculate? We calculated the molar mass of XY2 and again, we calculated the molar mass of X3Y2 as well. We calculated the mass of 1 mole of XY2 and this is the mass of 1 mole of X3Y2. These are the 2 things which we calculated till now, right? Now understand. My dear students, if you remember, in the last session, I told you one simple thing. Since molar mass is expressed in grams, what about molecular mass? This 100 grams, it is the mass of 1 mole of the compound. If I ask you, what will be the mass of 1 molecule of this XY2? What will be the mass of 1 molecule of X3Y2? You just have to change the units. Instead of grams, you have to write either AMU or you can write U. So, if I ask you, what about the molecular mass? if I ask you, what about the molecular mass of XY2? You will say the molecular mass of XY2 is going to be 100 U exactly. Similarly, what about the molecular mass of X3Y2? You'll be writing the molecular mass of X3Y2 has to be how much? Just replace the units. Instead of grams, you can write either AMU or you can write U. So you got the molecular mass of both the compounds. You got molecular mass of both the compounds. Now, my dear students, since you got the molecular mass, what is molecular mass? What does molecular mass mean? Molecular mass is basically the sum of atomic masses. Let's assume the atomic weight of X is A. Let's assume the atomic weight of Y is B. So I would say the molecular mass of XY2 is 100 U, and molecular mass actually is the sum of atomic weights. If the atomic weight of X is A, so I can make one equation. A plus 2 times B will be equal to 100 U. This will be one equation. Similarly, second equation, it's going to be 3 times A plus 2 times B is equal to 180 U. So 3 times A plus 2 times B is equal to 180 U. Right? Dear students, you got two equations. You got two equations which contains two unknowns. Can we solve these two equations? Absolutely. Let's do one thing. Let's subtract equation 1 from equation 2. Let's subtract equation 1 from equation 2. So this will be minus, and this will be minus. So 2b got cancelled. 3a minus a comes out to be 2a is equal to 180 minus 100 comes out to be 80. So from here, a came out to be 40. And what was a exactly? A, I assumed the atomic weight of X, right? So it's going to be 40 AMU. 40 AMU is basically the atomic weight of X. Correct? Similarly, if I ask you, what about the atomic weight of Y? Since you got the value of A, put the value of A in any of the equations. If I put the value of A in the first equation, put the value of A as 40. So 100 minus 40 comes out to be 60. 60 divided by 2 comes out to be 30. So the value of B is coming out to be 30. And what was B? B was the atomic weight of Y, right? B was the atomic weight of Y. So you can write it as 30 AMU. These were the two things which I was supposed to calculate as far as the question is concerned. Let me know quickly in the chats if you got to know how to solve this sort of equation. Quickly, my dear students in the chats, everyone with the thumbs ups. Quickly, everyone. Let me know in the chats with the thumbs ups if every single thing is clear. Everyone, quickly. Yes, perfectly done. A lot of students have already given the answers. That's wonderful. That's great. Glad to see your answers. Perfect, guys. So this sort of a question, it can be asked in your NEET examination, or the ones who are writing JEE Mains examination. Even this sort of a question can be asked there as well, right? One simple concept which I used and solved the question. Okay. Now, let's move on to the actual stuff which we have to discuss in the today's session. What is that? That is average atomic mass of an isotopic mixture, right? Average atomic mass of an isotopic mixture. Before going into the depth of this particular topic, do you guys know what isotopes are? Do you have any idea of what isotopes are? It's a very simple terminology, right? I'm sure majority of you would have come across the term isotopes, correct? So let's see exactly what these isotopes exactly are. First of all, if I talk about the isotopes, what are isotopes all about? Understand properly what I'm going to say. How do we define the term isotopes? Isotopes are actually the atoms of same element. The atoms of same element having same atomic number, but different mass numbers. A very simple terminology. Isotopes are basically the atoms of same element which have got same atomic number but different atomic masses, but different mass numbers. For example, have a look. Have a look, understand. Since you would have heard about hydrogen, right? You would have heard about hydrogen. If I talk about hydrogen, hydrogen has got three atoms. Hydrogen has got three atoms which have got same atomic number. But different mass numbers. Here it's 1, here it's 2, here it's 3. Hydrogen has got three atoms which have got same atomic numbers but different mass numbers. So I will be calling these three atoms as isotopes of hydrogen. Similarly, if you talk about chlorine, chlorine has got two atoms. Which have got same atomic number but different mass numbers. One is 35, one is 37. So what do I call these two? I'll be calling these two atoms which have got same atomic number but different mass numbers. I'll be calling these two atoms as the isotopes of chlorine. So in general, how do I represent the isotopes? Have a look. Let's say we have got the element X. Let's say this is the element. I'm assuming this X has got three atoms. This element X has got three atoms which have got same atomic number. Remember, from now onwards, atomic number I'll be representing with Z. So I took an element X. It has got three atoms, same atomic number but different mass numbers. Let me call this as M1, let me call this as M2, let me call this as M3. Now my dear students, you tell me in the chats, what do I call these atoms as? I took an element X. These are the atoms of X which have got same atomic number but different mass numbers. Should I be calling these three atoms as the isotopes? Isotopes of what? Isotopes of this particular X. I hope you got to know the meaning of what isotopes exactly are. Yeah? Right, students? Simple. Now understand one thing. If I ask you, what is the mass number? What is the atomic mass of chlorine? If I ask you a general question, what is the atomic mass of chlorine? Now you must be thinking, how can we tell the atomic mass of chlorine? Because chlorine exists in two different isotopic forms. One isotope has got the atomic weight of 35 AMU and one more isotope has got the atomic weight of 37 AMU, right? Now if I'm generally asking you, what is the atomic weight of chlorine? You will say, sir, categorically mention which isotope you are talking about. Are you talking about Cl35 or are you talking about Cl37? This should be your answer, right? This should be your answer. If I ask you, what is the atomic weight of hydrogen? Now here you will have to think. Since hydrogen, it exists in three different isotopic forms. Protium, deuterium, tritium. This is called as protium. This is called as deuterium. This is called as tritium, right? If I ask you, what about the atomic weight of hydrogen? Now you must be thinking, hydrogen has got three isotopes. First isotope has got the atomic weight of 1 AMU. Second one has got 2 AMU. And the last one has got 3 AMU. Now which one am I talking about? Right? This has to be a common query among students. Perfect. Now my dear students, let me tell you one simple thing which you guys are going to remember from now onwards. Okay? Remember from now onwards. Understand what I'm going to say. For example, I'm taking an element X again, right? Let's say this X has got three atoms. Which have got same atomic number. But different mass numbers. This is M1, This is M2. This is M3. Perfect. Do remember, whenever the element exists in the form of isotopes, whenever the element exists in the form of isotopes, for the element which exists in the form of isotopes, what do we calculate? We calculate the average atomic mass of this X. That element which exists, which has got isotopes, we calculate the average atomic weight of this X, which is represented by MAV. Again, I'm repeating the same thing. Whenever the element exists in the form of isotopes, for that particular element which exists in the form of isotopes, we calculate the average atomic mass for that particular element, right? Now the point is, how do we calculate the average atomic mass? How do we calculate the average atomic weight? For that, just remember a few things for now, which I'll make you understand in some time, okay? Do remember. Whenever the element has got isotopes, for that particular element, we calculate the average atomic mass. Now, in order to calculate the average atomic mass, what do we need? We need the percentage abundances. We need the percentage abundances of the isotopes. We need the percentage abundances of the isotopes. Now, what are percentage abundances? You'll get the idea of percentage abundances in like 2 to 3 minutes. Just be with me, okay? Understand, whenever the element exists in the form of isotopes, we do not calculate the normal atomic weight for that element. We calculate the average atomic weight. And in order to calculate the average atomic weight of the element which exists in the form of isotopes, what do we need? We need the percentage abundances of the isotopes. I'm assuming the percentage abundance of this particular isotope is A, the percentage abundance of the second isotope is B, the percentage abundance of the third isotope is C. Either we need the percentage abundances or we need the mole percentage. What is mole percentage? Again, you'll get the idea in some time only. Okay? Again, you'll get the idea in some time only. Now, do remember, whenever the element has got isotopes, we calculate the average atomic weight for that particular element. In order to calculate the average atomic weight, what do we need? We need the percentage abundances of the isotopes. Once we get the percentage abundances of the isotopes, then you will have to make one formula. And what is the formula? It's very simple. M1 multiplied by A plus M2 multiplied by B plus M3 multiplied by C divided by A plus B plus C. This is going to be the formula which you guys will be using to calculate the average atomic weight of an element which exists in the form of isotopes. Which exists in the form of isotopes. I hope I'm clear to everyone. I hope I'm clear to everyone. I hope I'm clear to everyone. Point number one. Point number one. Point number two. Do remember one more thing. The sum of percentage abundances or the sum of mole percentage of all the isotopes of a particular element is always equal to 100. Now let's try to understand all these things a bit more in detail. Let's try to understand all these things a bit more in detail. Let's try to understand what these percentage abundances are. Let's try to understand what kind of questions can be asked from these 3 points. These are only 3 points which you need to know. Now we have to use these concepts. We have to use this particular concept in the questions. And how exactly? For that, let me make this concept a bit more clear to you. Have a look, people. Understand properly. I'm taking one example here. And what is the example? For example, let's say you have got chlorine. Let's say you have got chlorine, right? Since you must be knowing, it's one very simple thing. Chlorine exists in 2 different isotopic forms. One is Cl35, one is Cl37. Chlorine has got 2 isotopes, Cl35, Cl37. I told you a few minutes back, whenever the element has isotopes, what do we calculate for that element? We do not calculate the normal atomic mass. What do we calculate? We calculate the average atomic mass. We calculate the average atomic mass. In order to calculate the average atomic mass, what do we need? We need the percentage abundances of these isotopes. And let me tell you, the percentage abundance of these isotopes is equal to 75 and 25%. Right? 75 and 25%. These are the percentage abundances of these isotopes. Now, if you ask me, what is meant by these percentage abundances? Understand how you guys are going to remember it. Have a look, people. Have a look. Imagine entire chlorine in the universe exists in this room. Whatever chlorine is there in the universe, let's imagine that entire chlorine is present in this particular room. Let's imagine there are only 100 chlorine atoms in this room. Let's imagine 100 chlorine atoms are present in the universe and all the 100 chlorine atoms are present in this room. Now we know, if I talk about chlorine, it exists in two different isotopic forms. Can I say, out of total 100 chlorine atoms, there will be some Cl35 atoms and there will be some Cl37 atoms. Now, out of the total chlorine atoms, out of the total 100 chlorine atoms, let me tell you, 75 chlorine atoms will be present in the form of Cl35 and remaining 25 chlorine atoms will be present in the form of Cl37. That means in this room, if there are 100 chlorine atoms, out of 100, 75 chlorine atoms will be Cl35 and remaining 25 chlorine atoms will be Cl37. I hope you got the concept, you got the idea about what this percentage abundance is all about. Yeah? Right? Right, people? Perfect. Now understand. Since I took the element chlorine, it has got two isotopes. Whenever the element has isotopes, what do we calculate? Average atomic weight for that element. In order to calculate average atomic weight, what do we need? We need the percentage abundances. As you all must be knowing, these percentage abundances we represent with A and B. Percentage abundances we represent with A and B, right? Percentage abundances we represent with A and B. So this 35 I'll be calling as M1 and this 37 I'll be calling as M2. Now use the formula directly. What is the formula? Few minutes back I told you M1 multiplied by A plus M2 multiplied by B divided by what? Divided by A plus B. Now put the values in the expression. M1 value is 35, A value is 75, M2 value is 37, B value is 25 divided by A plus B. A plus B comes out to be 100. When you solve it, you get the average atomic weight of chlorine as 35.5 AMU. Now if I ask you, what is this 35.5 AMU? You'll say it is not the normal atomic mass of chlorine. It is basically the average atomic mass of chlorine which came out to be fractional. It came out to be fractional, right? It is the average atomic weight of chlorine here which came out to be fractional, right? This is not the normal atomic weight of chlorine. This is the average atomic weight of chlorine. I hope I'm clear to everyone. Let me know once in the chats if all the things are super duper clear to everyone. Quickly with the thumbs ups. Everyone. Everyone. Sir, are you in Jammu and Kashmir? Yes, I'm right now in Srinagar. In J&K, yes. I'm doing good, Yazni, thank you. Quickly, people, let me know if this particular concept is clear to you. Instead of A plus B, you can directly write 100, right? Because you know, the sum of percentage abundances of all the isotopes for a particular element, that's always 100, right? Perfect? Perfectly done? All right, if this is perfectly done, Let's try to solve certain questions. Let me see if you can answer them or not. Okay, there was one question which was asked in NEET long back. This was the question. Can't you solve this question now? You got the concept. You got the concept in detail. Now, this is the question. Understand. As far as this particular question is concerned, we have got the element boron. We have got the element boron, right? Boron is the element. As far as the question, boron has got two different isotopes. One is B10 and one more is B11. These are the isotopes of boron. And you know, whenever the element has got isotopes, what do we calculate for that element? We calculate the average atomic mass. In order to calculate the average atomic mass, what do I need? I need the percentage abundances or the mole percentage of these isotopes. Well, are the percentage abundances given to us? I think yes, 19%, 81%. So the percentage abundance of B10 is 19 and percentage abundance of your B11 that's given to us as 81. And you know, the percentage abundances are represented by A and B. So I'll be calling this as M1, I'll be calling this as M2. Now, can't you calculate the average atomic weight of boron? Can't you calculate the average atomic weight of boron? Absolutely. The formula is going to be simple. M1 multiplied by A plus M2 multiplied by B divided by what? Divided by A plus B. You know the value of M1. You know the value of A. M2 value you know. B value you know. A plus B will be 100. Put all the values and get the average atomic weight of boron, which you were supposed to calculate as far as the question was concerned. Yeah? Right, people? Is it clear to everyone quickly in the chats? Quickly, my dear students. Well, after putting all the values in this particular expression, since M1, A, M2, B, A, B, everything you know, all the parameters are given here. I've mentioned all the parameters. Put them into the expression, get the desired answer. And the answer of this particular question will come out to be 10.8. Yeah? So 10.8 AMU is going to be the average atomic weight of boron, which we were supposed to calculate. Quickly, let me know in the chats if everything seems clear. Quickly, let me know in the chats if every single thing seems clear to you. Quickly, my dear students, everyone. Quickly, everyone. Let me know if all the things are clear to you. Just a second. What's happening to this here? Just a second, people. Oh my God. What just happened? Just a second, just a second. Okay. All right, let me give you one more question now. Let me see if you can solve this question or not. One more question I'm going to give you. Understand and try to solve this question, okay? Understand and try to solve this question. The question is, for example, like this. For example, you have got the element magnesium. Let's say you have got the element magnesium. This is the question basically. Try to solve this. Let's say you have got the element magnesium. Let's assume magnesium has got three isotopes. One is Mg24, one is Mg25, and one more is Mg26. These are the three isotopes of magnesium. These are the three isotopes of magnesium. For example, the average atomic weight of magnesium, as far as the question, let's say it's given to you as 24.31 AMU. This is, for example, the average atomic weight of magnesium. And at the same time, the percentage abundance of Mg24, it is given to us as 79. And what are we supposed to calculate? We are supposed to calculate the percentage abundance of Mg25 and Mg26. This is the question. Can you solve this? Can you solve this? Magnesium has got 3 isotopes, right? The percentage abundance of one of the isotope is given to us. The average atomic weight of magnesium is given to us. And we are supposed to calculate the percentage abundance of Mg25 and Mg26. Can you solve this one? Just give it a try quickly in the charts. Just give it a try. Just give it a try quickly. So let me show you exactly how do we deal with these sort of questions. Understand guys. Since few minutes back, I told you the sum of percentage abundances of all the isotopes of a particular element, that's always 100. You know that, right? The sum of percentage abundances of all the isotopes of a particular element, that's always 100. Now, if the percentage abundance of the first isotope is 79, let's assume the percentage abundance of Mg25 is, for example, X. Let's say this X is the percentage abundance of Mg25. This one has got 79. The percentage abundance of the second isotope is X. So what do you think should be the percentage abundance of Mg26? What do you think? It's going to be 100 minus 79 plus X. Do you agree with all this? Do you agree with this? The percentage abundance of first isotope is 79. The percentage abundance of second isotope is X. So the percentage abundance of third isotope has to be 100 minus this plus this, because we know the sum of percentage abundances of all the isotopes of a particular element, that's always 100. Correct? As simple as that. Now, dear students, 100 minus 79 plus X, it comes out to be how much? It comes out to be 21 minus X. It comes out to be 21 minus X. And you know, the percentage abundances, we represent with A, B and C. We represent with A, B and C. This is the value of M1, this is the value of M2, and this is the value of M3 here. This is the value of M3 here, right? Since average atomic weight of magnesium is given, how do we calculate the average atomic weight actually? Formula you already know. Instead of MAV, I'll be writing M1A plus M2B plus M3C. Divided by what? Divided by A plus B plus C, that's always 100. And this is already given to us as 24.31. It's already given to us as 24.31, right? Now, dear students, M1 value is given to us as 24. A value is given to us as 79 plus M2 value is 25, B value is X, M3 value, that is 26, and C value, that is 21 minus X, divided by what? Divided by A plus B plus C, comes out to be 100, and this particular value is equal to 24.31. Now, my dear students, look at this particular equation. Look at this particular equation. Do you see one equation and just one variable, that's X? Yes, we got one equation, one variable. One equation, one variable, right? So you just need to cross multiple here and get the value of X, right? And when you solve it, the value of X, you'll find out to be the value of X coming out to be 11%. And what was X here? What was X here? X was the percentage abundance of Mg25. X was the percentage abundance of Mg25. So what should be the percentage abundance of Mg26? Percentage abundance of Mg26 is equal to C, and C is nothing, that's 21 minus 6. That is 21 minus 6. X already you calculate, that's 11, so 21 minus 11 comes out to be 10%. So this 10% and 11%, these are the respective percentage abundances of Mg26 and Mg25, which we were supposed to calculate as far as the question, right? Is this super clear to everyone? Quickly, let me know in the chats, everyone. From this concept, this is the toughest question that can be asked. Rest all the questions are going to be directly formula based, okay? Just tell me in the chats if you got the concept properly. Quickly. Quickly, people, everyone. Everyone, let me know quickly in the chats if you got this particular concept properly. Someone is saying Sprite clear. Yeah? Who has taught you this Sprite clear? What is the timing of my class? The timing of my class is 7 p.m. Right? Do remember this timing. Every day from now onwards, I'll be taking class at 7 p.m. And we are starting with class 11th, mole concept. This chapter will take almost some 7 sessions, right? And we'll be following the NCERT routine. After this, we'll be doing atomic structure, then carrying on. Yeah? Perfect, guys. So I think you all should be able to solve all the questions based on this particular concept, right? And majority of the times, if the question is asked from this, that question will be of the direct formula based one. Okay? Now let's move on. Let's move on to something which is really, really very important. Something basics, and you will see in a while how slowly we are going to scale up the things. I'll be starting from exact basics. Slowly we'll be scaling the things up. Okay? Now, people, calculation of moles, right? How do we calculate number of moles? There are some 3 results which I would want you guys to remember directly. 3 direct results which I would want you guys to remember. Later on, I'll show you from where those results actually come, right? Number 1, how do we calculate number of moles of a substance? Calculation of moles. Let me tell you, number of moles of any substance is represented by, first of all, N. And how do we calculate it? The first formula, which you guys are going to remember from now onwards, what is that? Calculation of number of moles. Number of moles calculation. The first formula. That is given mass of the substance in grams divided by molar mass of the same substance. This is the first formula by means of which you can calculate number of moles. I'll show you the application in some time. Just be with me. How do we calculate number of moles? The first result is given mass of the substance divided by molar mass of the substance. The first formula. Second formula to calculate moles. Number of moles, which is represented by N, can be calculated through one more formula. What is that? That is given number of particles divided by Avogadro's number. This is one more result by means of which you can calculate number of moles of any substance. I'll show you its application in some time. Just wait for it. The third formula to calculate number of moles is valid only for gases. And the gas has to be kept at STP. The gas has to be kept at STP. STP stands for standard temperature pressure, right? Where temperature is kept as 0 degrees centigrade, right? And pressure is kept as 1 bar, or you can say 1 atm, right? Let me write 1 atm here. This is the STP condition. This third formula which I'm going to give you, it's valid only for gases, and the gases have to be present at 0 degree and 1 atm pressure. The temperature of the gas should be 0 degree and the pressure of the gas should be 1 atm. Then only you can use this particular result which I'm going to give you. What is that? It is simple. Given volume of the gas in liters divided by 22.4 liters. Or for example, if the given volume of the gas is in milliliters, then the denominator should be also in milliliters. So it has to be 22400 milliliters, right? These are the three basic results which I would want you guys to remember for now. The first formula to calculate moles: given mass of the substance divided by molar mass of the substance. Given number of particles of a substance divided by Avogadro's number. Given volume of the gas in liters divided by 22.4, right? Let me show you some basic questions so that you can understand these formulas. Let me show you that first. Have a look. For example, I'm writing 160 grams of NaOH. Let's say I have got 160 grams of NaOH in the container. Okay? Let's assume I have got 160 grams of NaOH in the container. Now I'm asking you how many moles of NaOH are there in the container. I'm asking you how many moles of NaOH are there in the container. Now you tell me whether we are given with the mass of NaOH, or are we given with the number of particles of NaOH, or are we given with the volume of NaOH. Accordingly, we'll use the result. Accordingly, we'll be using the result. We are given with 160 grams of NaOH. That means we are given with the mass of substance. And whenever mass of substance will be given to you, and you will have to calculate moles, how do you do that? Given mass of the substance divided by molar mass of the substance. That's it, right? So I would say number of moles of NaOH will be equal to given mass of the substance is 160 grams divided by, what is the molar mass of NaOH? What is the molar mass of NaOH? See, sodium, its atomic weight is 23 mu, oxygen, it's 16, hydrogen, it's 1. When you solve it, value comes out to be 14, right? Now, since you need the molar mass, so its units has to be grams per mole. Its units have to be grams per mole, right? So, given mass of the substance divided by molar mass of the substance. Grams cancel, the value comes out to be exactly 4 moles. Now, it's completely your choice whether you want to say that you have got 160 grams of NaOH in the container, or you can say you have got 4 moles of NaOH in the container. The choice is all yours. The choice is all yours. If you want to say you have got 160 grams of NaOH in the container, or you want to say we have got 4 moles of NaOH in the container, the choice is all yours. You can talk in terms of grams, or you can directly talk in terms of moles. No issues at all. Yeah? No issues at all. For example, I'm writing a statement. Let's say I'm writing 24 into 10 raised power 23 atoms of carbon. Let's assume we have got 24 into 10 raised power 23 atoms of carbon in a container. And I am asking you, how many moles of carbon are there in the container? How many moles of carbon are there in the container? Now, first of all, look. Are we given with the mass of carbon? No. Are we given with the number of particles of carbon? Absolutely, we are given with number of particles of carbon. And when we are given with number of particles, what do? Given number of particles, divide by Avogadro's number. Given number of particles, divide by Avogadro's number. We are given with the particles of carbon. So I'll be using the second result. Given number of particles, which is 24 into 10 raised power 23, divided by Avogadro's number, which is approximately 6 into 10 raised power 23. The value comes out to be 4. Now it's again your choice whether you want to talk in terms of number of atoms, or you can directly talk in terms of moles. You can say we have got 24 into 10 raised power 23 atoms of carbon in the container, or you can say we have got 4 moles of carbon in the container. The choice is all yours. Okay? Now similarly, if I write something like this, 67.2 liters of carbon dioxide gas at STP. Let's say I've got a container which contains a gas. Which gas? Carbon dioxide. I have got, for example, carbon dioxide gas in the container. We have got 67.2 liters of carbon dioxide gas in the container. And this carbon dioxide is present at STP. That means the pressure of carbon dioxide is 1 atm in the container, and temperature of carbon dioxide in the container, that's 0 degrees centigrade. Now I'm asking you, how many moles of carbon dioxide are there in the container? I'm asking you, how many moles of carbon dioxide are there in the container? First, understand, are we given with mass of carbon dioxide? Are we given with number of particles of carbon dioxide? Are we given with the volume of carbon dioxide? We are given with the volume of carbon dioxide in liters. So I'll be using the third result, right? That's given volume of carbon dioxide, which is 67.2 liters. Divide by what? Divide by 22.4 liters. The value exactly comes out to be 3. Now it's completely your liberty whether you want to say that we have got 67.2 liters of carbon dioxide in the container, or you can directly say we have got 3 moles of carbon dioxide in the container at STP. It's completely your call. It's completely your choice. Yeah? Is it clear to everyone? Like, I gave you just these 3 basic points so that you can use the formula directly from now onwards. You just have to see whether we are given with mass of substance, or are we given with the number of particles of the substance, or are we given with the volume of the substance. Okay, one more thing. Let's say I'm writing 48 into 10 raised power 24 molecules of carbon dioxide gas. Let's say we have got a container which contains these many molecules of carbon dioxide. Have a look. In the container we have got these many molecules of carbon dioxide, and I'm asking you how many moles of carbon dioxide are there in the container. First have a look. Are we given with the volume of the gas? No. Are we given with the mass of the gas? No. Are we given with the particles? Yes, we are given with the particles. Particles can be given either in terms of atoms, or it can be given in terms of molecules, right? We are given with the particles of the substance. Now, how do you convert particles into moles? Given number of particles, divide by what? Divide by Avogadro's number, approximately 6 into 10 raised power 23. The value comes out to be 6 8s are 48, and it's going to be 80. Now, completely your choice, whether you want to say that you have got these many molecules of carbon dioxide, or you have got 80 moles of carbon dioxide in the container. Let me know quickly in the chats if every single thing seems clear to you. Everyone, people, quickly in the chats. Quickly. Is every single thing clear till here? Yeah? Perfect. Let's continue and let's have a look on few more interesting and amazing things. Let's have a look on few more things. Have a look, guys. There is one very simple and basic diagram which I'm going to give you, and by following the diagram you can solve some basic questions from the mole concept, the convergent questions, which I'll let you know in some time. First, let's have a look on the diagram. See guys, whatever I've taught you till now, I'm going to use the same thing, okay? Since in order to calculate number of moles, how many ways we have to calculate number of moles? Either we can be given with the mass of the substance in grams, or we can be given with the number of particles, or we can be given with the volume, right? So all the 3 ways we have discussed, right? The first thing, if you are given with the mass of the substance, if you are given with the mass of the substance in grams, if you want to convert the given mass of the substance into number of moles, if you want to convert given mass of the substance into number of moles, how do you do that? Given mass of the substance divided by molar mass of the substance. Given mass of the substance divided by molar mass of the substance. That gives me the number of moles of a substance, right? If I do the reverse thing, if moles of the substance are given and we are supposed to calculate mass, if moles of the substance are given and we are supposed to calculate mass of the same substance, what do? Number of moles of the substance multiplied by molar mass. Given mass divided by molar mass gives us number of moles. Number of moles multiplied by molar mass gives us the given mass. It's a simple formula, right? Number of moles is equal to given mass of the substance in grams divided by molar mass. So given mass divided by molar mass gives me moles. If you want to calculate mass, That means number of moles multiplied by molar mass. Number of moles multiplied by molar mass gives me the mass of the substance in grams. I'll show its application in some time. Just wait for it. One more thing. If we are given with the number of particles, if we are given with the number of particles of any substance, if we are given with the number of particles of any substance, what do you have to do? Divide the given number of particles, divide the given number of particles by the Avogadro's number, you'll be getting the moles. If I reverse the thing, if you want to convert number of moles into number of particles, if you want to convert number of moles into number of particles, then you just have to multiply number of moles by Avogadro's number, you'll be getting the number of particles. Similarly, if you are given with the volume of the gas in liters at STP, let's say volume of the gas at STP in liters is given to us, and you want to convert the given volume into number of moles, what do? Given volume of the gas in liters divided by 22.4 liters, it gives me the moles. Or if you want to do the reverse thing, number of moles multiplied by 22.4 liters, it gives me the volume of the gas at STP. Now, let's have a look how exactly we are going to utilize this particular result, this particular diagram, right? This particular diagram. Let's have a look. Let's have a look. My dear students, just one thing you need to remember. You just have to follow the arrows. If I'm telling you convert moles into mass, then you have to multiply moles by the molar mass. You'll be getting mass. If I'm asking you convert moles into particles, you have to follow this arrow, which takes you from moles to particles. If I ask you convert volume into moles, then you have to follow this arrow. Given volume divided by 22.4 liters, that gives me the moles. If I'm asking you convert moles into volume, that means this arrow you need to follow. Moles multiplied by 22.4, that gives you the volume in liters, right? Now, let's have a look what kind of different questions we can solve from this basic diagram. Have a look, understand. Since you got the relation between moles and mass, you got the relation between moles and particles, you got the relation between moles and volume, did you get some direct relationship between mass and particles? No, right? No. Did you get the direct relationship between mass and volume? No. Did you get the direct relationship between volume and particles? No. Right? So if I ask you, how do we convert volume into mass? How do we convert mass into particles? How do you convert particles into volume? What do we have to do? We just have to follow the arrows. What does that mean? Have a look. I'm writing one very simple question so that you can understand it properly. One very simple question I'm writing so that you can understand it properly, okay? Basic question. The question is like this. Calculate the mass of 67.2 liters of carbon dioxide gas at STP. Calculate the mass of 67.2 liters of carbon dioxide at STP. What does it mean? It means you have got a container, and in the container you have got 67.2 liters of carbon dioxide which is present at STP. I am asking you, what will be the weight of it? What will be the weight of 67.2 liters of carbon dioxide at STP? I'm asking you that. Will you be able to solve this? My dear students, how these sort of questions are to be solved? Have a look. First thing, in the question you have to look what we are supposed to calculate and what we are given with. Just have a look at the statement. Calculate the mass. Calculate the mass. So we are supposed to calculate the mass. And what are we given with? We are given with the volume of gas. We are given with the volume of gas. So we are given with volume and we have to calculate mass. We are given with volume and we have to calculate mass. That is the point, right? We are given with volume. We are given with volume and we have to calculate mass. Is there any direct relationship between the two? No. Now what you are going to do? You will be following the arrows. You are given with volume, you have to calculate mass. You are given with volume, you have to calculate mass. Whatever quantity you will be given with, you'll be starting from that quantity. Since we are given with volume, so I'll be starting with volume. And I will be following all the arrows which will take me from volume to mass. I'll be following all the arrows which will take me from volume to mass. That means first, I'll have to follow this arrow so that I reach at moles. Then I have to follow this arrow so that I reach at mass. That's it. That's how you convert volume into mass. Now what is the first step? Given volume divided by 22.4 liters gives you the moles. Moles multiplied by molar mass gives you the mass. That's it. Two steps. Two steps. The first step is to calculate number of moles of carbon dioxide. How exactly? Given volume divided by 22.4 liters. That gives you the moles. What is the given volume? 67.2 liters. Divide by what? Divide by 22.4. The value comes out to be 3. So basically you have got 3 moles of carbon dioxide. Now moles you got. Now moles you have to multiply with the molar mass. You'll be getting the mass. So I'll be writing the mass of carbon dioxide will be equal to moles of carbon dioxide multiplied by the molar mass of carbon dioxide. Now if I ask you how many moles of carbon dioxide we have? 3. What is the molar mass of carbon dioxide? You can calculate 44 plus 32. Sorry. 12 plus 32 comes out to be 44 grams. So multiply with 44. The value comes out to be 132 grams. So you can clearly say the mass of 67.2 liters of carbon dioxide at STP will be simply 132 grams. Isn't it very simple, my dear students? Isn't it very simple, my dear students? Quickly. Quickly, people. All clear? Give me some thumbs ups in the chat so that I'll understand you got it properly. Sir, how many classes will be held in a week? Every day I'll be taking class at 7. Every day at 7 I'll be taking a class. Okay? I hope this is clear to everyone. For example, I'm giving you one more question. Let me give you one more question. Let me see if you can solve that or not. Let me give you one more question. Yeah, what's happening? Just a second. Okay, let me give you one more question. Let me see if you can solve this or not. The question is, again, a very simple one. Calculate the number of molecules. Calculate the number of molecules present in 448 liters of carbon dioxide gas at STP. At STP. Can you solve this question? Can you solve this question quickly? It's again a simple one. First of all, you have to see what we are given with. We are again given with the volume of gas. And what are we supposed to calculate? We are supposed to calculate number of molecules. We are supposed to calculate the number of particles. We are given with volume and we are supposed to calculate particles. So we'll start from that quantity whose data is given. We'll start with volume. We'll end at number of particles. We'll start at volume. We'll end at particles. We'll start at volume and now we'll end at particles. Now, is there any direct relation between volume and particles? There is no direct relation as such. So I'll be again following the arrows. What all 4 arrows will take me from volume to number of particles? I'll be using those arrows. So the first arrow has to be this one, which will take me till moles. Then I will have to use this particular arrow, which will take me from moles to particles. As simple as that. So again, 2 steps. First step, given volume, divide by 22.4. That gives me the moles. Moles multiplied by Avogadro's number. That gives me the particles. That's all. That's all, right? Right, people? So the first step is to calculate number of moles. How exactly? Given volume of the gas in liters divided by 22.4 liters, the value will be 20. So we calculate the moles. Now, how do we calculate the molecules of carbon dioxide? Moles to molecules, moles to particles. We just have to multiply moles by the Avogadro's number. That will give you the molecules. So the answer is simply 20 Na. Or you can put the value of Na exactly as 6.02 into 10 raised power 23. So I can say the container which I have, in which there are 448 liters of carbon dioxide. In 448 liters of carbon dioxide, there will be exactly these many molecules of carbon dioxide present. Right? I hope this is clear. I hope this is again clear to everyone. Perfect. I hope this is again clear to everyone. Yeah? Similarly, there can be few more questions. For example, mass will be given and you will be supposed to calculate particles. Mass will be given, you will be supposed to calculate particles. For example, let me give you one more question. Let me give you one more question. Let me see if you can solve that or not. Let me see if you can solve that or not. Let's say I'm giving you the question. Calculate the number of atoms. Calculate the number of atoms present in 36 grams of carbon. Basic question this is. That means you have got a container which contains 36 grams of carbon. You have to see how many atoms of carbon are present in the container. How many atoms of carbon are there in the container? Now you have to look for two things. First, what is given? We are given with the mass of substance. What are we supposed to calculate? We are supposed to calculate the number of atoms, number of particles. Mass is given. Particles we have to calculate. Whatever is given, start from that. So start from mass and add particles. Start from mass and add particles. Start from mass and add particles. So here you'll be starting from mass. You'll be ending at particles. So what all arrows take you from mass to particles? Just follow those arrows. First arrow has to be this one. This has to be the first arrow. Second arrow has to be this one. Done and dusted. What was the given mass of carbon? 36 grams. Divided by molar mass of carbon, 12 grams, right? So 36 divided by 12 comes out to be 3. So you got 3 moles of carbon. 3 multiplied by Avogadro's number, you got the atoms of carbon, particles of carbon. So 3 Na is the answer. Is it simple? Isn't it simple, my dear students? Yeah, very simple, right? So this diagram is very important, and this is a basic diagram by means of which you can convert different things. You can convert mass into volume, volume into moles, moles into particles, etc., etc. Yeah? Perfectly done? Okay, if this is done, let me see if you can solve this particular question or not. Let me see if you can solve this one or not. Give it a try once. Give it a try once, quickly. Give it a try once. The question is very, very, very simple. Have a look, people, understand. Mass of an atom of an element X. So we have got the element X. The mass of one atom of X is given. The mass of one atom of X is given. Calculate the number of moles present in 19.2 kg of it. So basically, imagine that you have got a container, and in this particular container, what do we have? We have got 19.2 kg, which means 19200 grams. So in this container, we have got, for example, 19200 grams of X. In this container, we have got these many grams of X, right? We have got these many grams of X. We have to check how many moles of X are there in the container. We have to check how many moles of X are there in the container. So first of all, check, are we given with mass of substance? Yes, we are given with mass of X. What do we have to calculate? Moles. How do you convert mass into moles? Given mass divided by molar mass. So number of moles of X will be simply equal to mass of X in grams divided by molar mass of X. What is mass of X in grams? It is 19200 grams. Do we know the molar mass of X? We do not know the molar mass of X. What is meant by molar mass of X? Molar mass of X means mass of 1 mole of X. Are we given with mass of 1 mole of X? No. We are given with mass of 1 atom of X. We are given with mass of 1 atom of X. But what do we need? We need mass of 1 mole of X. Right? So can I say, first I need to calculate molar mass of X. What is meant by molar mass of X? Molar mass of X means mass of 1 mole of X. Mass of 1 mole of X means? Mass of 1 mole of X means 1 mole contains Na particles. So we have to calculate mass of Na particles of X. It can be written as mass of Na particles of X. Mass of Na particles of X. Mass of Na particles of X. Can't I write it like this? Mass of 1 particle of X, or mass of 1 atom of X multiplied by Avogadro's number. Can't I write it like this? What about the mass of 1 atom of X? It's given to us, I believe, 1.6 into 10 raised per what? 10 raised per minus 23 grams multiplied by Avogadro's number, approximately 6 into 10 raised per 23. So this term cancel. This value will be how much? 9.6 grams. So if I ask you, what is this 9.6 grams? Is this 9.6 grams the mass of 1 atom of X? No. This is the mass of 1 mole of X. This is the molar mass of X. We were given with the mass of 1 atom of X. So I multiplied the mass of 1 atom of X by Avogadro's number. I got the mass of 1 mole of X. I got the molar mass of X. Right? So molar mass of X we got to know as 9.6. And its units are grams per mole, right? Just solve it, get the number of moles of X, which we were supposed to calculate, right? Let me know quickly in the chats if it is super clear. Quickly. Quickly, people, is it clear? Is it clear to everyone? We were given with the mass of X, and we calculate the moles of X. Given mass divided by molar mass. We were not given with the molar mass. We were given with the mass of 1 atom of X. So mass of 1 atom of X multiplied by Avogadro's number. That gives me the mass of 1 mole of X. Mass of 1 mole of X is something which I call as molar mass of X, right? Yeah? Perfect. Wonderful. Now, dear students, can you solve this one? Can you give it a try? Can you give it a try? How many moles of electrons weighs 1 kilogram? Understand the language carefully. How many moles of electrons weighs 1 kilogram? What does it mean? What does it mean? That means you have got electrons in the container. That means you have got electrons in the container. You have got 1 kg of electrons. You have got 1000 grams of electrons in the container. You have got 1000 grams of electrons in the container. I'm asking you, how many moles of electrons are present in the container? So mass is given. We have to calculate moles. How do we convert moles? How do we convert mass into moles? Number of moles of electron is equal to given mass of electron in grams divided by molar mass of electron, right? What is the given mass of electrons? It is 1000 grams divided by. Do we know the molar mass of electron? What is meant by molar mass of electron? That means mass of 1 mole of electron. Mass of Na electrons, mass of 6.022 into 10 raised power 23 electrons. Can I write molar mass of electron as mass of 1 electron, which is 9.1 into 10 raised power minus 28 grams, multiplied by Avogadro's number, 6.022 into 10 raised power 23. Can I say this whole term gives you the molar mass of electron? This term is mass of 1 electron multiplied by molar mass. So this whole term now will give you the molar mass of electron, the mass of 1 mole of electron, the mass of 6.022 into 10 raised power 23 electrons. So given mass divided by molar mass. Just solve it. Get the number of moles of electrons present in 1000 grams of it. Isn't it simple? Isn't it simple, my dear students? You were given with 1000 grams of electrons in the container. And I was asking you, how many moles of electrons are there in the container? What did you do? Given mass of electron, divide by molar mass of electron. What is molar mass of electron? Mass of 1 electron multiplied by Avogadro's number. That is the molar mass of electron, right? Clear? Let me know in the chats with the thumbs ups quickly if it is super clear to everyone. Let me know quickly in the chats, my dear students. everyone. Everyone in the chats, quickly. Everyone in the chats, quickly. Yeah? Quickly, people, everyone. Perfect? All right, if this is clear till here, let me tell you some more important things then. And what are those important things? I'm writing the heading over here as calculation of atoms, electrons, protons, neutrons, and ions. How do you calculate? How do you calculate atoms, electrons, protons, neutrons, ions, etc.? See, understand what I'm going to tell you. There is a particular set of questions in which you will be supposed to calculate the total number of atoms. Some questions in which you will be supposed to calculate electrons. Some questions in which you will be supposed to calculate protons. Some questions in which neutrons, right? Ions, etc. How to deal with those questions? How to deal with those questions? There is one simple diagram which I'm going to give you. I would want you guys to remember that diagram and solve the questions. First, I'll be giving the diagram. Then I'll give you certain questions. Then I'll give you certain questions which you will solve, right? Which you will solve, and you'll get to know how do we do the calculation of atoms, electrons, protons, etc. Remember the diagram first. Remember the diagram first. Remember the diagram first. I'm writing something as given quantity. I'm writing the term here as given quantity. Then I'm writing number of moles. Then I'm writing number of moles. I'm multiplying moles by Avogadro's number. I'm writing here the molecules. From the molecules, we can calculate atoms, electrons, protons, neutrons, ions, etc. What is meant by this diagram? How do we use this diagram? Have a look. First thing, whatever will be given to you in the question, whatever, whether you are given with mass of substance, whether you are given with number of particles of substance, whether you are given with volume of the substance, whatever you are given with in the question, that's something you call as the given quantity. That's something which you call as given quantity. Your first step always should be to convert the given quantity into moles. Given quantity can be in terms of mass. You know how to convert mass into moles. Given mass by molar mass gives you moles. If it is in volume, given volume divided by 22.4 liters gives you moles. So first step always, do remember, is to convert given quantity into moles. Right? Number one. This is always step number one. Step number two. If the given substance is in molecular form, like carbon dioxide, like O3, like O2, if the given substance is in molecular form, then you need to convert moles into molecules. You have to just multiply moles by the Avogadro's number, you'll be getting the molecules. From molecules, you can calculate anything. For example, one basic question I'm writing here. Calculate the total number of atoms. Calculate the total number of atoms present in 67.2 liters of carbon dioxide gas at STP. This is one basic question which we have. For example, you have got a container, and in the container you have kept some 67.2 liters of carbon dioxide. In the container you have got 67.2 liters of carbon dioxide. I'm asking you, how many total number of atoms are there in the container? I'm asking you the atoms. I'm asking you to calculate the atoms, right? Calculate the atoms. Do you see atoms in this diagram? Yes, I can see it here. So I have to follow this diagram, right? What this diagram says, convert the given quantity into moles. What is given to me as per the question? I'm given with volume of the gas. I'm given with volume of the substance. So given quantity is in terms of volume. So convert the given quantity into moles first. Do you know how to convert volume into moles? Yes, we know. So first step is to calculate number of moles of carbon dioxide. It is given volume of carbon dioxide in liters divided by 22.4 liters. The value comes out to be 3. That means either you can say that we have got 67.2 liters of carbon dioxide in the container, or you can directly say we have got 3 moles of carbon dioxide in the container. So we are done till here. Now check whether the given substance is in atomic form or molecular form. It is in molecular form. It's carbon dioxide molecule, right? It is in molecular form. Now what you have to do? Number of moles multiplied by Avogadro's number. That gives you the number of molecules. So my second step is to calculate number of molecules. Number of molecules of what? Number of molecules of carbon dioxide. How exactly? How exactly? Moles multiplied by Avogadro's number. Moles are 3 multiplied by Avogadro's number. So these many molecules of carbon dioxide are there in the container. Initially, you only knew how many liters of carbon dioxide are there in the container. Then you got to know how many moles of carbon dioxide are there in the container. Now you got to know how many molecules of carbon dioxide are there in the container, right? You got to know in the container how many molecules of carbon dioxide are there. There are 3 Na molecules of carbon dioxide in the container, correct? Now if I ask you something like this, 1 molecule of carbon dioxide, 1 molecule of carbon dioxide. Can you tell me in 1 molecule of carbon dioxide how many atoms are there? Can you tell me that? In 1 molecule of carbon dioxide there is 1 carbon atom, 2 oxygen atoms. So in 1 molecule of carbon dioxide there are in total some 3 atoms. In 1 molecule of carbon dioxide there are 3 atoms, right? In 1 molecule of carbon dioxide there are 3 atoms. But in the container, do you have 1 molecule of carbon dioxide? No. How many molecules of carbon dioxide you have? You have got 3 Na molecules of carbon dioxide, right? Now dear students, in 1 molecule of carbon dioxide, we have got 3 atoms in total. But in the container, we do not have only 1 molecule of carbon dioxide. We have got 3 Na molecules of carbon dioxide. So 3 Na molecules of carbon dioxide will contain 3 multiplied by 3 Na atoms. The value comes out to be 9 Na atoms. So basically, what did you calculate? You calculated the total number of atoms present in 67.2 liters of carbon dioxide at STP. These are the total number of atoms in the container. These are the total number of atoms in the container, right? Yeah? It's simple, guys. It's simple. 1 molecule of carbon dioxide contains 3 atoms. 2 molecules will contain into 2. 3 molecules will contain into 3. 4 molecules into 4. 3 Na molecules will contain into 3 Na. That's it. Simple, right? Okay, one more thing if I ask you here. Can you let me know, out of total 9 Na atoms in the container, how many oxygen atoms will be there? How many oxygen atoms will be there? Out of total 9 Na atoms, how many oxygen atoms will be there? I can again write one similar statement. In 1 molecule of carbon dioxide, how many oxygen atoms are there? In 1 molecule of carbon dioxide, there are 2 oxygen atoms. Now imagine, if in 1 molecule of carbon dioxide, there are 2 oxygen atoms. But in the container, do I have 1 molecule of carbon dioxide? No. How many? We have got 3 Na molecules of carbon dioxide. In 1 molecule of carbon dioxide, there are 2 oxygen atoms. So in 3 Na molecules of carbon dioxide, there will be 2 into 3 Na. The value will be 6 Na oxygen atoms. Right? Total 9 Na atoms. Out of 9 Na atoms, there are 6 Na oxygen atoms. That means the remaining will be carbon atoms. So how many carbon atoms will be there in the container? Number of carbon atoms in the container will be 9 Na minus 6 Na. The value will be 3 Na. So 3 Na carbon atoms will be there in the container. Isn't it simple, people? Isn't it simple? Yeah? Isn't it simple? Just give me a second. Perfect? Perfect? All right. One more question I'm giving you. Let me see if you can solve that or not. Let me see if you can solve that or not. For example, I'm writing a question here. One basic question I'm writing, okay? Now you know how to deal with it, right? The question is simple. Calculate the or let me write it like this. Calculate in 360 grams of glucose. Calculate in 360 grams of glucose. Number one, total atoms. Number two, carbon atoms. Number three, hydrogen atoms. Number four, oxygen atoms. This is one more question which I'm giving you. Can you give it a try? Can you give it a try, people? Calculate in 360 grams of glucose. You have to calculate atoms, right? Atoms calculation. So second diagram you'll be using. What is the first step? Convert the given quantity into number of moles. Given quantity is in terms of mass. We are given with the mass of glucose. So my first step will be, what will be my first step? You know it. Convert the given quantity into number of moles. So first of all, I will be calculating the number of moles of glucose, which will be equal to given mass of glucose in grams divided by molar mass of glucose, which is 180 grams per mole. The value comes out to be 2. Now it's completely your choice whether you want to say that you have got 360 grams of glucose, or you can say you have got 2 moles of glucose. So first step is done. We have converted the given quantity to number of moles. Now I'll be calculating. The second step is calculation of molecules. How do you convert moles into molecules? Multiply the moles by the Avogadro's number. So these many molecules of glucose we have, right? So we have solved the equation till molecules. We have solved the equation till molecules. Where is that diagram? We have solved the equation till molecules, right? Yeah, we have solved the equation till here. Now from molecules, we have to calculate atoms. We have to calculate atoms. And how exactly? See, I'll write one simple statement. One molecule of glucose. One molecule of glucose. Can you let me know, in one molecule of glucose, how many atoms will be there? There are 12, there are 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. So 6 plus 12, that's 18. 18 plus 6, that's 24. So in one molecule of glucose, there are in total some 24 atoms. Right? In one molecule of glucose, there are in total some 24 atoms. Right? But if I ask you whether we have only one molecule of glucose, no. In one molecule of glucose, no doubt there are 24 atoms. In 2 molecules of glucose, multiplied by 2. 3 molecules of glucose, multiplied by 3. 4 molecules of glucose, multiplied by 4. 2 Na molecules of glucose, multiplied by 2 Na. 2 Na molecules of glucose, multiplied by 2 Na. So 24 multiplied by 2 Na, the value comes out to be 48 Na atoms in total. So in the container, there are in total these many atoms present. In total, there are these many atoms present, right? These are the total number of atoms present in 360 grams of glucose. Okay, this is done. Now you tell me then. Now you tell me. Since you have calculated the total number of atoms. Since you have calculated the total number of atoms, now calculate the carbon atoms. Simple again. You'll write one simple statement. In one molecule of glucose, contains 6 carbon atoms, right? If one molecule of glucose contains 6 carbon atoms, 2 Na molecules of glucose will contain 6 into 2 Na. That means 12 Na carbon atoms. So these many carbon atoms are there, right? Now if I ask you how many hydrogen atoms are there, you'll again write one statement. In one molecule of glucose, there are 12 hydrogen atoms. If in one molecule of glucose, there are 12 hydrogen atoms. So in 2 Na molecules of glucose, there will be 12 into 2 Na. That means 24 Na hydrogen atoms. 24 Na hydrogen atoms. Similarly, you can calculate oxygen as well, right? In one molecule of glucose, there are 6 oxygen atoms. So in 2 Na molecules, there will be 6 into 2 Na. That means 12 Na auxiliary atoms will be there in the container. Is it super clear to everyone? Is it super clear to everyone? You got to know how do we deal with the calculation of atoms? Yeah? I hope you got to know how do we calculate atoms. First step, calculate moles. Second, if the given substance is in molecular form, then multiply the moles by the Avogadro's number, you'll be getting the molecules. Once you get the molecules, you can easily calculate atoms. That's it. Yeah? Perfectly done? Okay, this was the calculation of atoms. Now let me show you how do you calculate the electrons, protons. Let me show you how do we calculate the electrons, protons, okay? Understand now. First of all, few basic things I must tell you before doing the calculation of electrons, protons, neutrons, etc. Since you know the formula which we have to use, what is that? Whatever is the given quantity, convert the given quantity into moles. Multiply the moles by the Avogadro's number, you'll be getting the molecules. If the given species is in molecular form. From molecules, we can calculate atoms, we can calculate electrons, we can calculate protons, we can calculate neutrons, etc., etc. Right? This is the general formula. Before using this general formula, if I ask you, let's say we have got the element X. I've taken one atom of X, whose atomic number is Z, whose mass number is M. And there is no charge present on this atom. There is no charge present on this atom. I'm asking you, in one atom of X, how many electrons are present? Do remember, in one atom of X, there are Z electrons present. How many protons are present? There are Z protons present. How many neutrons are present? Neutrons are calculated by M minus Z, mass number minus atomic number. These many neutrons are there, right? If the atom is electrically neutral, whatever is the atomic number, same is the number of electrons, same is the number of protons in one atom of element. And neutrons, M minus Z. Okay? Neutrons, M minus Z. Perfect. For example, you've got a case like this. Let's say this is X now, whose atomic number is Z, whose mass number is M. Right? And there is, for example, a charge of plus N on this atom. There is a charge of plus N on this atom. Now I'm asking you, now it becomes an ion basically because it is the atom carrying the charge. That means it's the ion. So in this one ion, how many electrons are there? How many protons are there? How many neutrons are there? How do you calculate that? Since it is a cation basically, there is a positive charge. It is a cation. So in this cation, how many protons are there? There will be again Z protons. How many neutrons are there? M minus Z neutrons. Only change will be in the electrons. How many electrons will be there? Electrons will be Z minus N. These many electrons will be there. Okay? Similarly, if there is an ion, for example, this is X, atomic number Z, mass number M, and there is a charge of minus N here. So it is an anion. It is a negatively charged atom. Right? So if I ask you, in one anion, how many protons are there? Protons are always same. Nothing happens to protons and neutrons due to charge. Okay? Nothing happens to protons and neutrons due to charge. Yeah? Nothing happens to protons and neutrons due to charge. Neutrons are again same, M minus Z. These are neutrons. Only thing that changes is electrons. It is a negatively charged atom now. It has gained electrons. So how many electrons will be there? Z plus N. These many electrons will be there. I hope this is clear. Let me give you certain examples also. Okay? You tell me just one thing. Just tell me one thing. For example, we have got sodium. The second example I'm taking, let's say we have got Na positive. The third example I'm taking, let's say we have got N tri-negative. Do let me know the electrons, protons and neutrons in them. Since this sodium, it does not have any charge. Atomic number 11, mass number 23. How many electrons? Whatever is atomic number, same electrons. How many protons? 11. How many neutrons? Mass number minus atomic number, 23 minus 11. 23 minus 11 comes out to be how much? comes out to be 12. So 12 neutrons. 11 electrons, 11 protons, 12 neutrons. Now, Na positive. Atomic number 11. Mass number 23. How many protons? Due to charge, nothing happens to protons. Protons will be 11 only. Whatever is atomic number. Neutrons. Again same. 23 minus 11. Nothing happens to neutrons. It's 12. Electrons will change. There's a positive charge. If there was no positive charge, then it should have 11 electrons. But there is a positive charge, that means it has lost 1 electron. So there are 10 electrons. And try negative. Protons. Protons, 7. Neutrons, 14 minus 7. Electrons, 7. There is a negative charge. 3 unit of negative charge. That means it has gained 3 electrons. So 7 plus 3 comes out to be 10. So 10 electrons, right? Simple and basic again. Yeah? So I hope this basic is also clear to you. Now let me tell you a few more things. Have a look. Now I'm giving you a question. The question is very simple. I'm writing, calculate the total number of electrons, protons and neutrons in. Calculate the total number of electrons, protons and neutrons in. For example, in 44.8 liters of carbon dioxide gas at STP. This is the question. Just let me know in the chats whether you can solve this one or not. First of all, have a look, what are we supposed to calculate? Electrons, protons, neutrons. So which diagram I'll be using? The second diagram. In the second diagram, the first step is convert the given quantity into moles. This is my given quantity. Convert it into moles. So convert volume into moles. So my first step is to calculate the number of moles of carbon dioxide. Will be equal to given volume of carbon dioxide in liters divided by 22.4 liters. The value comes out to be 2. So first step is done. Second is number of molecules of carbon dioxide. Number of molecules of carbon dioxide. How do you convert moles into molecules? Multiply moles by the Avogadro's number. You'll be getting the molecules. So these many molecules of carbon dioxide we have. These many molecules of carbon dioxide we have. Now, what do we have to calculate? Electrons. We have solved the equation till molecules. Now we have to calculate electrons. How you are going to calculate electrons? One statement I'll be writing in terms of electrons. If I ask you, in one molecule of carbon dioxide, how many electrons are there? In one molecule of carbon dioxide, how many electrons are there? One molecule of carbon dioxide. One molecule of carbon dioxide. This is 6, this is 12. This is 8, this is 16. This is 8, this is 16. In one molecule of carbon dioxide, there will be 6 plus 8 plus 8 electrons. That will be 8, 8, 16 plus 6, 22 electrons. There will be 22 protons also. Neutrons, 12 minus 6 is 6. 16 minus 8 is 8. 16 minus 8, 8. So it's going to be 6 plus 8 plus 8, again 22 neutrons. So we got to know in one molecule of carbon dioxide, there are 22 electrons, 22 protons, 22 neutrons. Correct? Now, if in one molecule of carbon dioxide, 22 electrons, 22 protons, 22 neutrons, how many molecules of carbon dioxide we have? We have got 2 Na molecules of carbon dioxide. So, in 2 Na molecules of carbon dioxide, how many electrons will be there? In one molecule, 22 electrons. 2 Na molecules, it's going to be 44 Na electrons. Similarly, 44 Na protons. Similarly, 44 Na neutrons. Right? I mean, in one molecule of carbon dioxide, there are 22 electrons. 2 molecules multiplied by 2. 3 molecules multiplied by 3. 2 Na molecules multiplied by 2 Na. Everywhere multiplied by 2 Na. Get everything. That's it. Yeah? Clear to everyone? Is it super clear to everyone? It should be. So I hope you got to know how to deal with the calculation of electrons, etc., etc. Okay? Perfectly done. If this is done, let's solve then one more question. Let's solve one more question then. Let me see if you can do this or not. Now the question is, I'm writing a question. Calculate calculate the total number of valence electrons in 4.2 grams of N tri-negative. Calculate the total number of valence electrons in 4.2 grams of N tri-negative. I'm asking you about the valence electrons, right? Be careful. What am I given with? I'm given with the mass of substance. What is the first step? Convert the given quantity into moles. So let's calculate the number of moles of N tri-negative. That is equal to given mass of the substance in grams divided by. What is the molar mass of N tri-negative? Whatever is the molar mass of nitrogen, same will be the molar mass of N tri-negative. Due to the presence of charge, nothing happens to molar mass. Whatever is the molar mass of magnesium, same is the molar mass of magnesium dipositive. Whatever is the molar mass of O, oxygen, same is the molar mass of O di-negative. Due to charge, nothing happens to the molar mass. So molar mass of nitrogen, you know, that's 14 grams per mole. The value of dissolving comes out to be 0.3. So first step is done. We have converted the given quantity into moles. Given quantity into moles. It's done. Now check if the given substance is in molecular form or not. It's not in molecular form. If it was in molecular form, then what we were supposed to do? We're supposed to multiply moles by the Avogadro's number. We would have got the molecules. But is this in molecular form? No. It's in ionic form. Now what I'll be doing? From moles, directly I'll be calculating ions. How? Moles multiplied by Avogadro's number. Moles multiplied by Avogadro's number here directly gives me ions. The way, if it was a molecule, then moles multiplied by Avogadro's number gives me the number of molecules. Now this is ion. It is an ion. So moles multiplied by Avogadro's number, that gives me directly the number of ions. Okay? Now, if I talk about 1N tri-negative, atomic number 7. How many total electrons are there? 7 plus 3. There are total 10 electrons. Out of 10 electrons, can I say 2 electrons will be there in the first shell and 8 electrons will be there in the second shell? Can I say this particular shell I'm calling as the valence shell? Can I say these 8 electrons I'll be calling as the valence electrons? Absolutely. So can I say in 1N tri-negative, how many valence electrons are there? There are 8 valence electrons. In 1N tri-negative, there are 8 valence electrons. In 2N tri-negative, multiplied by 2. 3 multiplied by 3. 4 multiplied by 4. 0.3 Na ions. 0.3 Na N tri-negative ions will contain 8 multiplied by 3. 8 multiplied by 0.3 Na valence electrons, which comes out to be 2.4 Na valence electrons. So these many total number of valence electrons will be there in 4.2 grams of N tri-negative. Is it clear? Is it clear, my dear students? This sort of a question can also be asked. Okay? Now, if this is clear, can you solve these questions? These 3 questions? Can you solve these questions? Can you solve them? Let's give it a try. Let's give it a try. The first question is, calculate the number of atoms in 16 grams of helium. So the first question is, we are given with 16 grams of helium. Helium is given in atomic form. Okay? We are supposed to calculate the atoms. Use the diagram. Convert the given quantity into moles. So number of moles of helium is equal to given mass of helium divided by molar mass of helium. The value comes out to be 4. So we have calculated the moles. Now this species is in atomic form. So moles multiplied by Avogadro's number won't be giving you the molecules here. They'll be directly giving you the atoms. So I'll say number of atoms. Number of atoms of what? Number of atoms of helium will be simply equal to 4 multiplied by Avogadro's number. This is something which we are supposed to calculate as far as the first question is concerned. These are the total number of helium atoms which we are supposed to calculate. So first question is done. Second, atoms in 16U of helium. 16U. In the beginning it was 16 grams. We know whenever mass of substance is given in terms of grams, then we have to divide the given mass of substance in grams by the molar mass, we'll be getting moles, right? But here we are given with 16U of helium. 16U of helium. See how I'm going to convert it. If I talk about helium, what is the atomic weight of helium? 4U or 4 AMU, right? 4U is the atomic weight of helium. It is the mass of one atom of helium. So 4U means one atom. How many U we are given with? 16U. 16U. If I multiply this equation by 4, 4 4s are, it becomes 16U. This becomes 1 into 4 is 4. Can I say indirectly 16U is equal to 4 atoms of helium? So indirectly here we are given with 4 atoms of helium. Indirectly we are given with 4 atoms of helium, right? Perfect. Done. That's something which we were supposed to calculate. We were supposed to calculate atoms of helium. We have calculated 4 atoms of helium, right? We have calculated 4 atoms of helium. Correct? That's something which we are supposed to calculate. Simple. The third one. Calculate the number of oxygen atoms in 126 AMU of HNO3. Okay. If I ask you what is the molecular mass of HNO3, you can calculate it. 1 plus 14 plus 16 into 3. That will be 120. That will be 63. 63 AMU is equal to 1 molecule of HNO3 basically. 63 AMU is equal to 1 molecule of HNO3. Am I given with 63 AMU here? No, it's 126 AMU. Let's see what it is. If I multiply this equation by 2, this becomes 126 AMU. And this becomes 2 molecules. It becomes 2 molecules. So basically, or indirectly, 126 AMU means 2 molecules. It means 2 molecules of HNO3. It means we are given with 2 molecules of HNO3. But are we supposed to calculate molecules of HNO3? No. We are supposed to calculate oxygen atoms. Can I say in 1 molecule of HNO3, there are 3 oxygen atoms? In 1 molecule of HNO3, there are 3 oxygen atoms. If in 1 molecule of HNO3, there are 3 oxygen atoms. In 1 molecule of HNO3, there are 3 oxygen atoms. So, in 2 molecules of HNO3, there will be, in 2 molecules of HNO3, there will be 3 into 2. That means 6 oxygen atoms. In short, this is something which we are supposed to calculate. That's all. I hope it is clear. I hope it is clear. Yeah? Perfectly done? Perfectly done, people? I hope it is super clear. These were 3 questions basically which I gave. These were 3 questions which I gave. Now I'm giving you 1 question as the homework. Rest of the things we shall be discussing in the next session, which is tomorrow, right? Do join the tomorrow session as well, which is at 7 p.m. Okay? 1 question I'm giving you as the homework. Give it a try and do let me its answer in the comment section of the video. Okay? The question is, for example, let's say I'm writing a question. Calculate the total number of atoms, electrons and protons in 128 grams of SO2 gas. This is the question, a very simple one, right? I would want its answer in the comment section of this particular video, right? I would want its answer in the comment section of this particular video once the video ends. This is your question, this is your homework. Do let me know in the comment section of the video what is the answer of this particular question. From now onwards, your sessions are going to be regular. At 7 p.m. every day, you'll find me here on this channel, Unacademy NEET English, right? I have dedicated some 7 sessions for mole concept, right? So today was the 2nd session, tomorrow it's going to be the 3rd session. Do join that as well. And on 25th, we are starting the NEET 2024 AVENGERS batch on the Unacademy platform. The ones who have not joined yet, link is there in the description box of the video, right? To join that AVENGERS batch also. That's going to be something which will boost up your ranks in your NEET 2024 for sure, right? Again, in the AVENGERS batch, we'll be starting from class 11 syllabus first, then class 12. In 6 months, your whole class 11th as well as class 12 syllabus will be done and dusted. right? In physics, chemistry, as well as biology with the Avengers team. Link is there in the description box of the video. There is right now some 20% off going on. Let me quickly show you how to enroll into the batch. Let me quickly show you how to enroll into the batch. Just a second. See guys, this is the video which you guys are watching right now. Just drag it a little down. Here you have got a link, batch link. Click on the link. After clicking on the link, you have to put your number, or you can continue with the email, right? And there is some 20% off going on, and get enrolled into the batch as soon as possible. The batch is almost filled now, right? But still there are a few vacancies, so you guys can join in as soon as possible. Yeah? Perfect? Yes, Jinendra, yes. Perfect, guys. So with this, I'll be taking a leave. I'll see you guys tomorrow at 7 p.m. Till then, you guys take care. God bless you all, love you all, and do let me know the answer of the question in the comment section of this video. Take care. Bye-bye.